Colloquially known as the brown snake, the Brisbane River is the city's lifeblood. Its role in the lives of Brisbane's 2.4 million residents centres upon industry, travel and utility, a place for recreation and the provision of home water supply. Locals are justified to hold a vested interest in the health of the river. However, as Dawson's 2012 research suggests, disregard for the waterway and its environment is the commonly shared perception of locals. Understanding the river's past and present is a means of perceiving and sustaining its future. This inquiry was researched across multiple platforms, including the Curtin University and Brisbane City Council library catalogues. Texts concerning sediment pollution were overwhelming, while accounts of other forms were limited, which made particular Boolean searches vital for locating a wider spectrum of information. The evolving human relationship with the Brisbane River has seen substantial changes to its catchments. Dixon's 2004 work points to early European accounts attributing the river with clear water and sandy banks, flanked by dense rainforest. Unfathomable today is Dawson's 2012 account of the 19th century river as both a food source and bathing facility. As settlement progressed, land use changed to allow for agriculture, metropolitan and industrial infrastructure. Sturzel's 2014 research links these changes to the increased turbidity and ultimate eutrophication of the river. Further accounts of chemical spills and dumping play a role of their own in the river's present condition. The research of Mueller, Duodu and colleagues demonstrates that pesticide use, sewage treatment, boatyards, industrial plants, heavy road and maritime traffic all contribute to the present environmental stress of the river. The impact of these organic and chemical contaminants is intensified by Brisbane's subtropical climate. The 2015 work of Kemp and colleagues suggests the river's unstable banks expose it to heightened storm and flood damage, eroding channels further and increasing the volume of toxic silt and minerals in the water. Sturzel's 2014 report argues the chronic mineral enrichment of the river has been the most significant cause of harm to its biodiversity, with deoxygenation of the water encouraging algal overgrowth and depleting more than 50% of the river's seagrass and mangroves. Davey and colleagues' 1990 research shows these native flora once provided habitats for 150 species of fish, over 30% of which have not been detected in the area for 50 years. The Queensland Government and Healthy Land and Water are present contributors to sustainability incentives. Through detailed environmental analyses and projects, these measures aim to restore degraded water and adopt sustainable land use. While fitting for the remediation of urban practices, these measures do fail to address implications for the community. The 2017 Healthy Land and Water report card found scores relating to community perception of the river were critical. The figures seen here depict a community lacking a connection to its natural environment, with little incentive to protect it. Perception and understanding of the estuary and its delicate ecosystem must be addressed for both the community and the environment to benefit. This inquiry is linked to the Australian curriculum for Years 5 and 6, where science understanding and science as a human endeavour content requires students to recognise the relationship between living things and their environment, and predict, research and present evidence of human contribution to nature. Also relevant is the cross-curriculum priority of sustainability, worldviews and futures, which requires learning within the health of ecosystems, relevant sustainability measures, and past actions which have negatively impacted the environment. These links highlight the importance of learning the actions and values required for a more sustainable future.